Hello everybody, I'm DayWeather meteorologist Don Day, and like what we've done over the last couple of winters, we're going to give you what we think the weather outlook will be like for this fall and through the winter and into the early spring season of 2023 and the 2024. We're going to give you our best guess on what we see coming, and we'll see what transpires. If you want to go back and look at what our prediction was for a year ago at this time for this past winter, you should be able to find it on our YouTube channel. What we're going to do here is we're going to break this up into two parts. For those of you that just want the long-range forecast without all of the discussion, you watch the first half of this. The second half of this is going to go into the weeds about how we formulated the long-range forecast, kind of the tools we use, kind of the thinking behind why we made the forecast we did. So if you want to just get the details about what the outlook is, the beginning of this video is for you. First of all, let's talk about the main climate factors coming for this winter. We do have an El Nino. Now, you've heard a lot of press reports that it's a super El Nino, that this is going to be a mega super El Nino. Well, we're really not there yet, and odds are it probably won't be a super El Nino. It's likely going to reach its peak sometime at the end of winter, or maybe mid to late winter. We'll actually see La Nina kind of reach its peak and then pull back a little bit. We're also going to be watching, as we always do during the winter season, is that Gulf of Alaska, the North Pacific, that sea surface temperature pattern, because that's really critical for the western United States. Not only is La Nina and El Nino important, but when we get to the cold season, what's going on in that North Pacific for western United States, western Canada, it's a really big factor. Also, this is a mouthful, but the quasi-biennial oscillation, better known as the QBO, may play an important role this year. We'll talk about that during the second half of this video. The sea surface temperature patterns, what's going on in the stratosphere, that being the QBO, and solar connections are all very important when we go into the winter season in terms of the dominant factors that drive the winter weather patterns across the northern hemisphere. And will the Tonga eruption that happened in early 2022 have an impact on this winter? We'll talk about that at the end of this video as well. So let's talk about this El Nino. Is it going to be a super El Nino? Probably not. While it is gaining strength, we don't think it's going to come across as strong as it has been advertised in the media. There's a lot of people in the media that, quite frankly, don't understand or really don't appreciate El Nino patterns and kind of jump the gun based on some modeling. But it certainly is going to be an El Nino dominated weather pattern through fall and into the early spring season. However, this El Nino will likely transition into what's called a Modoki, and we'll talk about what that is. Basically, it's a different flavor El Nino, especially at the end of the season. So it's likely going to be a hybrid season, a lot like last year was. Last year was La Nina at the start. The La Nina went away midwinter, and that really was a big reason why we ended up having such a snowy winter, especially after December, when things really got crazy in the West. Now, what we're likely going to see is it starts as an El Nino. By late winter and spring, it's a pattern of an El Nino that is going to be a little bit different. So last year was a hybrid. This year going to be a hybrid, but it's going to be of a different flavor. So what is a Modoki El Nino? We'll talk about that as we get into the weeds, so to speak. But let's go into the winter outlook for 2023. First of all, just kind of some of the highlights. The combination of a lot of the pattern, the El Nino, the QBO, the North Pacific, all of those things are likely going to result in an active winter season across all of North America. What I'm likely going to see in this pattern is that the winter weather will be felt more on a widespread basis this winter across the United States, especially Canada as well. Last winter, the most severe winter weather conditions were really focused in the West. There was a pretty mild winter for the Midwest and the East and the Northeast parts of the United States. This winter, I think the winter misery will be spread out more over a lot of the nation. So coast to coast, there's going to be more winter weather than last winter. But it may not be as focused as it was in the West during the 2022-2023 winter season. So we're going to have El Nino through most of the winter, turning into this Modoki by late winter and spring. Above average sea surface temperatures in the Gulf of Alaska and the North Pacific, that is a cold signal. Also a cold signal is a negative pattern at the equator in the stratosphere. Basically, the stratospheric winds near the equator go through reversals. Sometimes they blow from west to east, sometimes they blow from east to west, and that can end up impacting winter patterns. High solar activity as well tends to generate some very active jet stream patterns. So let's talk about what we see coming in the 2023-2024 winter season. Disclaimer, we got to throw this disclaimer in here. We can really only deduce trends. Trend is your friend in long-range weather forecasting. And what we do is we take historical trends, what we've seen in the past, we merge that with what the models are saying in the long term and see if there's any agreement there. Do patterns that we've seen before, like we're seeing now, do they match up with what the long-range forecast modeling suggests? And that always is an indication of whether or not you have high confidence or low confidence. Timing is difficult. Trying to time things when you're talking about a 4 to 5 month long forecast is really, really difficult. So we can't tell you what it's going to be like on January 3rd, July 3rd either. But we can tell you maybe what the trends are going to be and a general trend on timing. And remember, models are tools, not reality. Models try to give us a guide of what may happen based on projecting measured weather elements into the future. But when you see weather maps that are based on models, you have to take them with a grain of salt. So let's look at the outlook for 2023-2024. I think the potential for an early frost freeze is possible for most of the west and most of the northern plains. I say that because when we've had El Niños come on in the fall, we sometimes see the fall get off to an early start. If you remember, the last 2 or 3 falls have been extended. We've had really nice weather deep into the fall. I don't think we're going to see that this year. So it's going to be a cooler and more active fall season compared to the last 3. Most of the nation for this winter season is going to have above normal precipitation and snow. I do think the Pacific Northwest, eastward across the far northern Rockies and the far northern plains, may actually not have above average snowfall. And we'll talk about that in more detail. And most of the nation is going to be colder than average November through March. Now, there's going to be some parts of the country, I think, that won't be as cold relative to average, but this is likely going to be an impactful, cold, and occasionally snowy winter. We do think there's going to be another good snowpack year coming. This is going to favor the central and southern Rockies, the central and southern Sierras. We do think the Cascades, the Panhandle of Idaho, and Montana's snowpack may not fare as well. It's going to be kind of more directed into those southern and central areas. There will be Arctic outbreaks with the negative QBO. Arctic outbreaks like what we have had in the past few winters where you get these big pushes of Arctic air that go into the deep south, that's on the table this year as well. Europe is likely going to trend colder and snowier this winter compared to last winter as well. And that could have an impact on energy markets. So let's break it down into the smaller parts of the region, kind of get down onto the statewide levels. So for Northern California, Washington, Oregon, and Idaho, basically the Pacific Northwest, El Niños historically in the winter bring warmer and drier than normal conditions. Now, there are some long-range forecasts out there that are calling for a very snowy Pacific Northwest. We're not into that. We're not in that camp, let's say. And we say that because historically, if you get the season starting off with a rather robust El Nino, that tends to be a little bit of a warmer, drier signal in that part of the West. For Central and Southern California, the Great Basin states and the desert states, this is likely going to be another productive winter. We're expecting above average snowpack and above average precipitation. Historically, robust El Ninos in this part of the country do perform well with precipitation. So it could be another good water year, but I don't think it's going to be as far north as it was last year. There's a bit of a bias a little bit more south. The Dakotas, again, this kind of connects to the Pacific Northwest. While temperatures are going to be near average, and I really don't expect a really warm winter into those areas, El Nino winters have had a tendency to be warmer and drier at times, especially in North Dakota. So there may be, maybe not as severe winter weather conditions in the Dakotas this winter, especially North Dakota. Then you can extrapolate that into Alberta, Manitoba, Saskatchewan as well. For Kansas, Oklahoma, Texas, colder than normal, above average precipitation. El Niños of this type tend to go into the southern plains and be productive with a lot of winter weather and more storminess than the last 3 years for sure. Nebraska is kind of in between the Dakotas and the Kansas, Oklahoma, Texas pattern, but I do see Nebraska colder than normal, above average precipitation. Wyoming and Colorado, I think you're headed towards another couple of hard winters. And I forgot to add that this is probably going to be extending out maybe into the western counties of Kansas and western counties of Nebraska as well. I think it's going to be another hard winter. I don't expect it to be as severe of a winter because it's a little bit of a different animal compared to last year. But above average snowpack and a pretty robust winter season is expected in those two states. If we were to kind of draw this out, again, take this with a grain of salt, this is kind of rough, but the temperature anomalies, the areas of the United States relative to average that will be the coldest, will be the South and the Southeast. And then we have this stretch of near to below average temperatures from the southwestern United States through the Central High Plains and Rockies, and then further north, where this warmer, drier trend tends to be in the Pacific Northwest, could affect these areas that are more to the north. So relative to average, temperatures are going to be coldest in the central, the southeast, and the far south. Precipitation-wise, again, this is just kind of a guide, but these darker green areas are areas that we think have the ability to have a wetter than average season. The southeast, parts of the southern plains, parts of the central and southern plains, southwestern United States, and the central and southern Rockies, with the tendency maybe to be a little bit drier from the Pacific Northwest to the northern plains. Now, this is the second half of the video, getting into the weeds, so to speak, in terms of why we just gave you the forecast we did. This is where we were a year ago. The robust La Nina was well in place. This is where we are now. No longer La Nina. We've got a full-blown El Nino continuing to form. Look at the sea surface temperature anomaly in the North Pacific, from the Gulf of Alaska through the northern part of the Pacific. Now, this doesn't mean the water's warm. It would still be cold if you put your foot in it, put your toe in there. But it is a little bit warmer than average, enough that if we see this continuing into the fall and winter, is a cold signal. This is a cold signal right here, especially in the early fall. If we look at where we've gone, the changes that have taken place going back to 2021, for mid-August, this was the drought monitor in 2021. This is where it was about a year ago, and this is where it is now. So there's been significant improvements, especially in the far west when it comes to precipitation. The more droughty conditions, more towards the Midwest and Corn Belt and down here. Some drier areas, though, if you notice, have developed in the Pacific Northwest and the southwestern areas of the U.S. as well. So when we take a look in our long-term outlook, this is an area right here that I could think may continue the dryness in winter and spring. The El Nino is forecasted, the probabilities as we go into December, January, and February, better than 80% that El Nino will be here. But notice the trend. The modeling does show that the El Nino is actually going to weaken. It reaches its peak this fall. So this is why we don't think we're going to have a super El Nino. And also, we think it's going to be, as we mentioned at the beginning, a Modoki. Basically, the warm waters near the equator that you get with an El Nino can sometimes be in different locations in the Pacific. And what tends to happen in a Modoki is right now, the warmest sea surface temperatures are right here on the eastern side of the Pacific near the equator. And if we go back, you can see them right here. But as the winter goes on, we may see those warmer sea surface temperature anomalies move further west into what's called the Nino 3.4 region. Now, this is important because where the warmest waters are centered can affect the way the weather patterns are going to end up working. So when we go back, we tend to see the trend of those warmer temperatures work their way back westward. We think this is what's going to happen late winter and early spring. So the talk of a super El Nino through the entire season, we don't think is going to be correct. And we can go back into the early 90s, mid 90s, early 2000s, and see where these Modoki events have occurred in the past. Also occurring at the same time, as we mentioned at the beginning, a negative QBO. Now, we could do a whole video on this, but basically put, the wind patterns in the stratosphere go through these reversals about every 14 months. They've gone on since as long as we know that they've gone on. And these changes near the equator can distribute heat and water vapor across the equator and kind of change the dynamics of a winter season. When the QBO is from the west, it's a positive phase. That's where we were last year. This year, though, it's going into the negative phase. When you're in a negative phase, you have a weaker jet stream. When you have a weaker jet stream, you tend to have, and we talk about this in our podcast, stratospheric warming events, to where you have a warmer pattern in the stratosphere over the northern latitudes. That moves the cold air from the northern latitudes into the U.S., into Canada, most of Europe, and parts of Asia. So you tend to have a higher probability of stratospheric warming events in a negative QBO. This is where we are this winter, in the negative phase. The positive phase, you tend to have a stronger jet stream, and the opportunity for these events up here are less. It's not that they don't happen, but they're just less. And right now, if you look at the radiosonde, the stratospheric winds near the equator around Singapore, you can see that we're definitely in that negative phase. And what happens in a positive phase is the jet stream tends to be more confined, doesn't take as many meanderings as what we have in a negative phase. So we have an El Nino, we have a negative QBO going on. We've got a lot of sunspot activity right now. So you tend to have a more wavy jet stream pattern, which tends to lead to more extremes. You tend to get those storms that are stronger, the high pressure ridges that are stronger as well. You add that to the El Nino, and we're going to show you the sea surface temperature anomaly going forward is going to make for a very active and interesting winter. So here are the sea surface temperature anomalies, and what you want to do is watch in two areas. Here along the equator, then up here in the North Pacific. So you can see the El Nino, the warm North Pacific. Now, as we step through September, October, November, you see how the warmest temperatures are retreating westward? That is the signs of maybe a Modoki forming, a Modoki El Nino. This is December. Again, you can see the centering of the warmest sea surface temperatures have moved off the coast of South America and moved westward. We still have a warm North Pacific Gulf of Alaska. Again, that's a cold signal for North America. January, February, March. We still have the warm temperatures up here through that whole period. We still have some form of El Nino, but those warmer sea surface temperature anomalies continue to migrate more west. And then look at this by April and look at this by May. We actually have colder sea surface temperatures being forecasted by the Canadian model here. Now, whether or not we see that, but what we don't see here is a super El Nino. We just don't. We don't think that's coming to fruition. But El Nino is definitely going to impact the winter season, and this is by June of next year. So this is where we are now, and then by next June, we could be in a little bit of a different situation. So what we did is we went back and we did some reconstructions. And what we're doing is we're going to reconstruct Modoki El Ninos and years when we had El Nino to start and Modoki to end, kind of merging them together. So if you go back to the winter of 1997 to 1998, and this is from December 1 through the end of March, the blue shows temperature relative to average. So the much colder conditions during that Modoki winter of 97-98, the warmer temperatures were in Canada and along the East Coast. Again, don't take this as a forecast. This is just what happened those years. This is what the snowfall looked like that year. It was above normal here, and again, stretching into the Midwest. You see that drier tendency there in the Pacific Northwest as well. Now, if you go back to the Modoki of 2005, notice the warmest temperatures near the equator move towards the central part of the Pacific by April of that year. And this is important because we do think it's around that April, May, late March timeframe that those warmer temperatures will really be shifting east, and we may cool off here off the west coast of South America. So if you merge what happened in 2005, which may happen this year around the same time frame, if you merge the year of 1997 and 98 to April, May of 2005. You just kind of historically merge what happened. You can see this is precipitation. You can see the tendency here for above average precipitation here, back into California as well, and you could probably connect these two together. Hence, that's where we do think that tendency may be for above average precipitation. This is what temperature looked like as well. Again, it's really focused more in the western United States, but we do think that, as you saw on our map, this may be stretched out a little bit more east to west, and maybe we'll go maybe into this area right here more, and these areas up here may be a little bit warmer. But historically, these are the trends that we've seen in the past. The Tonga eruption. Let's take a look at that and let's talk about that a little bit, because we're getting conflicting stories in the media and what you're reading. So it's really confusing. First of all, every volcanic eruption is different. Each volcanic eruption is going to have different impacts due to the intensity, whether or not it was at a different low latitude, like near the equator, or high latitude volcanoes. Latitude makes a really big difference. Also, what they expel. Volcanic eruptions expel a lot of gases in the atmosphere, but the two most important ones for weather and climate are water vapor. That is the strongest greenhouse gas. That is the water vapor can make the biggest difference. The other thing is sulfur dioxide, SO2. Those are the two big emissions from volcanoes. And every volcanic eruption is going to be different. Now, what I'm showing you here is a measurement of water vapor at the equator going back to 2004. And what I want you to recognize, January 15th, 2022 is when the volcanic eruption went off. So you can see right here at the equator, a huge change in water vapor in the stratosphere happened after the volcanic eruption near the equator. Now, Tonga is in the southern hemisphere, okay? It's east of New Zealand. So it's fairly far south of the equator, but over time, you're going to see how it gets dispersed out. Now, water vapor, a big amount of water vapor in the stratosphere is actually a warming process. If you have a lot of water vapor getting put into the stratosphere, that is likely going to make surface temperatures warmer. It might be one reason, don't know yet, it's being debated, but it may be one reason why we kind of had a spike in temperatures, especially across parts of northern hemisphere this summer season, although it was really suppressed into those southern areas of the United States more than anything. But this is where you have a big change, measured, okay? This is measured, this isn't modeled. When we take a look at 45 degrees north latitude, notice that over time, that water vapor has gotten further north. So it crossed the equator, it was able to move more into the mid-latitudes. And notice when that happened, okay? It happened right at the beginning of the year. Now, this is also when we started to see the winter kind of change on us, where we did see some things change. Again, whether or not we can make that one-to-one lock on to say, well, our bad winter was because of the Tonga eruption. We're not saying that. But what we're saying is that it took a while for the northern hemisphere into the mid-latitudes, took a while for that water vapor to come on in. Now, let's go up to 75 north latitude, and while it's not as thick, there's definitely an increase is there as well. So, if we had a lot of water vapor move into the stratosphere, and we did a tremendous amount, it is likely going to have some impacts. The exact impacts I can't tell you. There's two camps out there. One is that since this was water vapor with not as much sulfur dioxide, the sulfur dioxide that came out of this volcano was less than Mount Pinatubo and less than other eruptions. Remember, this was an underwater volcanic eruption that transported a huge amount of water vapor into the stratosphere. SO2, sulfur dioxide, tends to have a strong correlation to making the surface temperatures cooler, not warmer. It's water vapor in the stratosphere that makes it warmer. So that is one thing that we're looking at, and we're going to basically have to look at this winter season and go back and look at the measured data to try to see what the impacts are. But if anybody's going to tell you exactly what those impacts are going to be with a lot of certainty, be careful. I want to show you this temperature spike that we had in July, the satellite-based temperature This is the best record of temperature. Going back to 1979 when satellites were measuring, this particular satellite was measuring, trying to get a handle on what the global temperature is. This is the best record we have going back to 1979. Notice we spent most of last year, right around the global temperatures near or just above the 30-year averages, so to speak. Really nothing remarkable, a tenth of a degree or so Celsius. But see this spike right here that happened in July? Could this be connected to the movement of that water vapor into the northern hemisphere more and the southern hemisphere as well? We'll see. But you got to remember, it's difficult to say. Be careful what you read in here. More study is needed. There's contradicting opinions. There is a camp out there that says Tonga had no impact and will not have an impact. Some people are saying there's a big impact. Honestly, I don't know what to tell you other than we got to observe this winter, take measurements, and have good science, and then we'll be able to have some opinions that are based more on science than people's opinions on what they think. Not all volcanic eruptions are the same, and neither are the potential impacts. So one volcanic eruption is not going to have the same impact as others. So bottom line is, could Tonga impact the winter? Maybe. Let's see. Most likely the impacts are going to be warmer conditions, measured warmer conditions. I think that's basically what we've seen this summer because it was more water compared to SO2. But could it lead to warmer temperatures this winter? We'll just have to see. But I think the overriding impacts of El Nino, as well as what's going on in the North Pacific, will have a bigger impact. The other impacts, we're just going to have to wait and see. Have yourself a good winter season. We'll see what happens. Thanks for listening and having your patience to get through all.